Okay, let's go and get started today. That'll be a short lecture because we have a lab to work on today. In the lab you're going to work on today, you're going to write some TCPIP code yourself. So let's just quickly talk about that and look at the lab sheet. So looking at this, last time we looked at kind of how the sockets library worked, how you write code to do both a server program, how you write code to do a client program, and today you're going to write one of each, and they're going to connect to each other, send some simple information, and talk to each other. So on the server side, relatively simple. You're going to open a port, do all the things you need to set that up to accept incoming connections. Once a connection is accepted, you'll exchange some data, and that'll be it for the server. The client is even simpler. You're basically going to do the stuff you need to open the socket, connect to the server at its address. After they're connected, again, exchange some data, and that's it. So let's quickly just take a look at the lab sheet, and let me explain a few things about it. So looking at the lab sheet, we basically have a couple things worth mentioning about that lab sheet. The first thing you'll notice is you're going to be doing this individually, so it won't be a group assignment. Let me zoom in just a little bit on that. So you're going to be working individually. It means that everybody should turn in your own programs. You'll be turning in both a client and a server, so make sure to submit both of those. And the code we're going to do in this, the TCPIP coding, it's going to be critical to understand sockets, how to open them, how to create a server, how to connect, how to close them for future labs that we're going to do. So I want everybody to be familiar with that. All right, the next thing about this is notice you're going to use kind of TCPIP programming using sockets in Windows. If you're not on a Windows machine, if you have a Linux machine, you can still do this lab. Just go back to the lecture. There was part of that said what the differences were between Unix /Linux and Windows. Relatively minor. Has to do with you don't have to do the WSA startup or WSA cleanup. You don't have to, or you use shutdown instead of close socket. Other than that, everything is pretty much the same. Now, if you're going to use this, I want you to do this in C, so don't do it in Python or something else. I want you to kind of see that lower level view of it to start with. So use it in C. We're going to use the WinSock2 library if you're in Windows. If you're not in Windows, you'll just use Berkeley Sockets, the sockets library that's in Unix. And what you're going to do is basically write two programs, the client and the server. And if you don't have an IDE to program in C, download code blocks, which will work. Install that. Make sure when you download code blocks, if you don't already have a GCC compiler installed, get the one that includes the MinGW compiler tools. Similar to what you should have done in systems programming, so you should be familiar with that. Or you can use Visual Studio to write this. Now, if you use Visual Studio, there might be some things you have to do to set up sockets. I haven't used Visual Studio for this, so you may need to Google some things to get sockets to work in that environment. All right, now the two programs. Program one, the client. Essentially, all you're going to do, open a socket, connect to the server program down here, and you're going to send a message. So that's all that this program is going to do. It's going to open a socket, use that socket to connect to the server, send that message, Watson, can you hear me? And then close the connection and exit the program. On the server, we're just going to do the same thing. We're going to read that message. In order to do that, we're going to have to open that socket, bind that socket to some unused port. You can pick whatever port number you want. There may be some ports that are already used for something on your machine. So pick a port like 0x1234 or something like that. You can kind of pick a port. If you pick one that's already in use, bind will fail. It'll give you an error message. So you'll know that if you've done that. One of the other things is when you open that port, after it's opened or bound, we have to listen, and then we have to accept. And so these are just Berkeley sockets or sockets function calls, WinSock function calls. And then after accept, though, is successful, we will now be connected. So we're just going to receive whatever message comes through. We're going to print it on the screen, and then we're going to close and exit. So this program, to test it, you're going to have to write both of them, compile both of them, run the server first. It'll then be opening, listening for connection, run the client. The client will connect, it'll send its data across, and you'll see the data show up in the server side. All right, now one thing that I have in the notes section here is each of those programs should return, or you should check the return values of those, so you should have error handling in there. Also, if there is some unexpected error, go ahead and print out what that error message is. So go ahead and try to print that out. The other thing is, if you want this to work, you guys could actually have your program talk to somebody else's program over the internet if you wanted to. But you might need to configure some sort of Windows firewall stuff. It might say, oh, this program is trying to open a port. Do you want to allow that? You may need to allow that to happen. All right. Make sure your programs compile. Make sure they work. Test them before submitting them. But realistically, that's all there is to this lab. Not particularly complicated. And the code is going to be similar to what was in the presentation from last time. So going back to the presentation here, we've looked at the lab. So really that's all I'm going to do today as far as lecture goes. Work on that lab assignment. You should be able to get that completely done today. There's not anything overly complex about that. It's very similar to the example code that was posted before. So work on that, get that turned in. And next time we're going to cover some a little more complex things and talk about like web servers and how you could actually create your own web server. So until next time, everybody stay safe and work on the lab. I'll see you soon. Well, I don't know what that means, but I'll see you soon on here.